So everyone just on your videos. Okay, so related to this input output time and CPU time, meaning that like a CPU may not be always with a process, like it has been like shifted from input output device to the process. So then this is a topic from last class, so I'm just reminding like giving you a reminder. So you have different time, like different terms like CPU utilization, throughput, turnaround time, waiting time, response time. These are important um, topics. So here your the first term is your throughput. As the name suggests, is nothing but the number of process completed per unit time. Okay, the number of process per unit time is nothing but throughput, and turnaround time is time taken by a process to complete execution, and waiting time is the time taken by a process in the waiting state. And you have response time is the time taken by a process to give fast response from the initial ready time or arrival time. Okay, so if you see the process, it first it has to come to this ready state. We call it as arrival time. Then it may have to have some waiting time. So if there is no waiting time will be zero. Like once a process come and it get execution, in that case it will be your waiting time is zero. In other cases it may be waiting for some other process. Okay, it just says wait a second.
Recording in progress.
So here the term, like you'll have the time burst time. Burst time is nothing but the time required by a process to complete. Okay, so you have this. First, it will be in once a process is arrived, it will be in ready state. If it gets the CPU, it will be in the run state. Once it completed, it will be in the completed state. So the term like you'll have waiting time, burst time, and completion time. Okay, and here are a few formula like to find your completion time minus your arrival time. It gives the value of your waiting time plus burst time, and your total turnaround time is nothing but your completion time minus your arrival time. So in problems you maybe have to find this waiting time, turnaround time. Okay, so you need to have an idea about this. So what is your waiting time, what is your turnaround time? So this is from your last class. So here we have two types of scheduling. As the name suggests, one is preemptive scheduling and another one is non-preemptive scheduling. Okay, preemptive scheduling, as the name suggests, is a one where in preemptive scheduling, a process in execution can be interrupted. Okay, a process in execution can be interrupted in preemptive scheduling, but in non-preemptive scheduling, once a process is in execution, then you cannot interrupt it. Means you cannot use the CPU. So until the completion of the process, the CPU won't be available. So that type of scheduling will be called as non-preemptive, where no interruption is done, and in preemptive scheduling, interruption can be done. Okay. Then we discussed that we have different type of algorithm, that is fast come fast serve, round robin. So today we are going to see this fast come fast serve and the shortage of fast. Okay, once we are done with today, then next week we are going to start the lab class, because your the first program will be based on all this scheduling algorithm. Okay, so the first algorithm is fast come fast serve. Okay, so we'll come to that. So everyone, turn on your videos. Everyone. So everyone turn on your videos, else I'll just remove one by one. Okay. Meanwhile, I'll start it, and in the meantime, I'll just remove one by one those who are not turning off their cameras. Okay. So as I said, we are going to discuss the scheduling algorithms. So the first is fast come fast serve. The second one is shortage of fast, and the third one is shortest remaining time fast. Okay. So coming to fast come fast serve, as the name suggests, whatever the process that come fast, the CPU will be given to that. Okay. So if we say we have two process P1, P2, they come in the order like P1 first and P2 second, then the process P1 will be given to the CPU first. Once it is done, then the process P2 will be given. Okay. So in this fast come fast serve, it follows your fast in fast out ready queue. Okay. So whatever the fast process that comes, the CPU will be given to that, and once it's done, it will be removed. So it follows your fast in fast out format. So in here, it's going to be non-preemptive until it is finished. As I mentioned before, that in non-preemptive, once the CPU is given to a particular process, the CPU won't be available to another process until completion. So your fast in fast out or fast come fast out is going to be your non-preemptive type, where you cannot interrupt once the CPU is given to a process. So it's simple to implement, understand. So the concept is simple, that whatever that comes fast, the CPU will be given to it. And average waiting time dependent on the order the process enter the system. Okay, it depends on the order the process is given to the system. Okay, just a second. So here we'll see the example of fast come fast serve. So here we have three process. Okay, we have three process P1, P2, P3. Okay, so don't see this figure and all as of now. Just see the question that we have three process P1, P2, and P3. Okay, they are arriving in the order P1, P2, and P3. Okay, so you have three process P1, P2, P3 arriving in the same order P1, P2, P3, and they have the burst time 24 units of time, 3 units of time, and 3 units of time. So as we know what burst time is, time required to complete the process. So everyone turn on your videos, Abhijit, Nila, Arvind. So it means that the question means that the first process P1 requires 24 units of time to complete it, and the second process P2 require 3 units of time, and third is also require 3 units of time. So in the exam, we are going to give the question in this format, like you will have this one, then solve it by fast come fast serve or whatever scheduling algorithm. So once you have this one, it is always easy to see it. So using this chart, which we call it as Gantt chart. Okay, so this pictorial representation gives you how the process will be completed. So once you have this question, just try to draw this one. How you are going to draw is you're going to make a line or a box like this, where the below gives you the time line. Okay, so at time 0, you'll have this process P1. Means at time 0, process P1 comes and it is given to the CPU. So as we know that your process P1 will require 24 units of time. So at 24 units of time, we'll make a line indicating that the process is completed at this point of time. Just a second. Okay, then so once we have this 24 units of time, it means that your process P1 is completed and the CPU is now free, and it has to be given to the next process. The next process is P2, right? So P2 will get the CPU at the time 24. Okay, at the time 24, and it will be used for how many units of time? As the name says, as the question says, we require 3 units of time, right? So from 24 to 27 units of time, your CPU will be allocated to the next process P2. Okay, at the point 27, your process P2 is completed, meaning that your CPU is free and it will be given to the next process. So the next process is P3, right? So from 27 units of time, it will take another 3 units of time, that is burst time of your process P3 is 3. So from 27 of time to 30 units of time, your process P3 will be using the CPU. So at the time, once it is completed, then the scheduling is completed. So if we look over here, so here we can even find out waiting time. Okay, so we just know that all these 3 processes come at the same time in this order. We assume that all the 3 processes come in this order at the same time 0. So if we consider for the first process P1, what would be the waiting time? Arvind, ready? Just tell me what would be the waiting time for this first process P1.
0, sir.
Exactly. So meaning that your process P1 comes and it gets the CPU. So the waiting time for your first process P1 is 0. What about P2? So your process
P2's waiting time will be how much time we will allocate the CPU for P1, like the number of the time which P1 will be allocated, 24.
Yeah, exactly. So your process P2 has to wait for the complete time of your previous process P1. So the waiting time for the process P2 is 24. Then the process waiting time for the P3 is 27. Okay. So so here also we have mentioned it. So waiting time for your process P1 is 0. Then process P2 is 24. P3 is 27. So once we have this, then even you can see the completion time. So completion time is what? For the first process, it completes at the units of time, that is 24 units of time. And for the second one, it completes at 27. Then for the third one, it completes at 30. Okay. So when you have this chart, it's very easy to get your waiting time, completion time from it. Okay. So once you have this waiting time, then the question usually asks you the find your average waiting time. So as we know that how to find average waiting time is addition of them divided by the number of process. So in this case, we have this 3 process, so we are adding their waiting time divided by 3. So equal to, so in this case it's 17, so 17 units of time. And for completion also, here you have the completion time. So addition of all those three, completion time divided by 3, it gives 27. Okay, so this is how your fast come fast serve scheduling works. Is there anyone who have any problem with this? Anyone? If you have any problem, just tell me, or if you want me to repeat it again. Okay. So lab problem will be based on this, the first lab problem will be. Okay, so I assume that no one have any problem. So here, what if the order has been changed to P2, P3, P1? So the same question, the same question with the same burst time, but the order of the process is different in this case. In the previous one, it was P1, P2, and P3. So let's see how, if order change, how it works. So if the order is P2, P3, P1, okay. So if the order is P2, P3, P1, so this is how your Gantt chart is going to look like. So as I said before, the first process is P2, so CPU will be given to the first process P2. So it will, the burst time of the first process P2 is 3, so it will use the time from 0 to 3. And second one is from 3 to 6, as P3 has 3 units of time and P1 has 24 units of time, so 16 to 24. And here are its corresponding waiting time. Waiting time for first one is 0, for the second one is 3, for the third one is 6. And here is its completion time. First one is it completes at 3, then second 6, then third 30. So here, so here is your average time. Okay, so average time is 3, 0 plus 3 plus 6 plus, so, and completion time also 13 in this case. So if you can compare with the previous question, previous situation, the process are same, means their burst time is same, the order are different, but their average waiting time and completion comes different, right? So this is why we say that in the slide that your average waiting time depend on the order the process enter the system. So in this scenario, the second scenario gives the better scheduling in this prospect because it gives less waiting time. Okay, so less waiting time meaning it completed things in a better way. Okay, so everyone have no problem with this? So here are a few pros and cons of this fast come fast serve. The first thing is it is very simple, so it's very easy to implement. And when we say about the cons, like your short jobs get stuck behind long jobs. Jobs refers to process. Okay, so in the first case, so if you look in the first case, you know that your second process P2 requires just 3 units of time, but it has to wait for 24 units of time. Okay, this is a problem. So here means it has to wait for long units of time, long waiting time. So this is a problem for this fast come fast serve. Okay, and your performance is highly dependent on the order in which the jobs arrive, as we see in these two examples that in the first case and the second case, when the order is different, their waiting time is becoming different, and the second one gives you the better one. Okay, so here we have this term or problem associated with this fast come fast serve. First, we call it as convoy effect. Okay, this is the problem that I just said before, that your short process has to be waited for a long time, as there is some long process in front of it, and it non-preemptive, as we cannot interrupt it, and it is not suitable for time sharing system. Okay, so these are problems associated with this fast come fast serve. So next comes the shortage of fast. So in this shortage of fast, your CPU is going to be given to the process with the least burst time. Okay, the one with the least burst time will be given the process fast. Here we have two types. One is non-preemptive and another one is preemptive. Okay, as we know, non-preemptive and preemptive. So here we have two types. So when we have like SJF, usually it means non-preemptive. Okay, and when we have shortest remaining time fast, it means preemptive. It can be interrupted. Okay, so it's very simple. As we assume that we have this four process arriving at different time, and they have this different burst time. Okay, when we talk about shortest job fast, in case of non-preemptive, as we say, we cannot interrupt it. Okay, I'll just keep this one. So in the previous case, we assume that all the process came at the same time 0. Here we have the process with different time arrivals. Even in the previous case also, we can have different time arrivals. Then it will go with the flow of this. So at time 0, there is only one process P1. Okay, at time 0, there is only one process P1. So bye. So in this shortest job fast, we have to trying to find the shortest one. So at time 0, there is no process, only one process P1. Okay, so your CPU will be given to the process P1. So it will start execution, and at time 2, we have another process P2. The means your process P2 arrives, but here the case is what we are discussing about non-preemptive, means no interruption. Non-preemptive means no interruption. So even though the second one has least burst time, still your process P1 needs to be given to the CPU won't be free until the process P1 is completed. So at time 2, your process P2 arrives, burst time is less, but since the CPU is used by the first process P1, it will be used till the time 7, as it's non-preemptive. At time 4, your process P3 arrives. At time 5, the process P4 arrives. So in this, between this time, all the other 3 process has been arrived. Okay, so once at the time process has completed at the time 7 units of time, then the remaining 3 is there. So when we have this 3 remaining, then we have to look for the shortest one. So the next shortest among these 3 is P3, right? P3 has the burst time of 1. So P3 will be given the CPU. So from 7 to 8, your CPU will be used by P3. And once it's completed, then we have to look for the remaining shortest job or shortest burst time. Then when we have this P2 and P4, when we have 2 burst time with the same, when we have 2 jobs with the same burst time, then we have to follow the fast come fast serve. Okay, so when we say this P2 and P4, they have the same burst time, but P2 arrives first, so the CPU should be given to the P2 first. So from 8 to 12, your CPU is given to P2, and from once it's done, P4 is given the chance. Okay, so this is your how the process will be executed for this given example in the non-preemptive shortage of first. Okay, so here is your average waiting time and all. Okay, then wait a second. So the explanation is there over here, but I think the time limit is there for me. So look here. So what would be the waiting time for process P1? So what will the waiting time for process P1 is? It arrives and it's gets the CPU, right? So process waiting time for process P1 is going to be 0. Then what about process P2? P2 arrives at the time so the process P2 arrives at the time 2, and when does it got the CPU? It got the CPU at 8, right? So how much waiting time it has to wait? It has to wait for 6 units of time. Okay, and when we say P3 arrives at 4 and it gets the CPU at 7, so it has to wait for 3 units of time. Then for P4, it arrives at time unit 5 and it gets the CPU at P4 at 12. So 12 minus 5, 7. Okay, so these are all waiting time. I think I don't have time for today. I'll just explain it again and I'll send in the Google Classroom. Okay. So the time limit is coming up. So everyone just I think I need to explain this one again. So if you have any problem with the fast come fast serve, just tell me. And those who are done, you can leave your attendance in the chat box. Okay. And next time, let me try to do the class in Google Meet. Okay. It's very difficult as I have time limit over here. So if you have any problem, just tell me. We'll discuss shortage of fast again. For fast come fast serve, if you have any problem, just tell me. Else, just give your attendance in the chat box, and you can leave the class. Okay. If anyone have any problem with this, okay, because you have to write program on this, so I'm just asking again and again because you need to understand it. So once you understand it, you have to write program on this. Lower.